Greetings everyone. Today is the day 13 of our PMP6 exam prep step by step. So let's see what we are going to do today. We are starting with a new knowledge area, which is the project quality management. Now, if we look at our process table, what we did in our last class was the project cost management. And there we saw there were 4 processes that we looked at. Just as a refresh, we looked at the plan, we determined the budget, and then finally we did control cost, where we dealt with earned value management or earned value analysis. Today we are stepping into our next knowledge area, which is the project quality management. And if we look at it closely, there are 3 processes in project quality management. One is in the planning process group, one is in the executing process group, and another, the last one that we'll talk about, control quality, is in the monitoring and controlling process group. Now, quality management is really about incorporating the policies and procedures in the organization so that it delivers quality products in the organization. And the second objective of this quality management is that it supports continuous improvement. It is not enough that we have a good quality in this particular project. We should have a process in place that continually improves all that we do in the organization and in future projects. The first process that we'll look at is the plan quality management. This is where we'll identify what are the quality requirements and how the project can comply with the quality requirements. Then we'll move into the next process, which will essentially translate the quality plan that we have drawn into executable quality activities. In other words, we'll determine from the plan what exactly we'll need to do in keeping up the quality, in managing the quality. And then finally, we look at the third process, which is the control quality. Now, control quality is about we assess the performance, and this is done typically just before we release the product out to the customer. And we want to ensure that before we send it out to the customer or the stakeholders or the users, we are releasing a quality output. Now, quality applies to all projects, regardless of deliverables. In other words, we might have different projects or different kinds of projects. It can have different deliverables. And we cannot have an excuse saying that, hey, we are doing this and we don't really want to worry about quality, because quality is applicable to all kinds of projects. It doesn't matter. It is a software project or if it's a construction project, quality matters. Even if you are building a nuclear plant, yes, if it matters. So whatever the deliverable, the quality does matter, and we should look at the quality aspect. Having said that, the measures and techniques that we might use, or the quality measures and techniques that we might use, will differ from project to project, will differ from deliverables to deliverables. For example, if it's a software project, we might have different types of techniques, like regression technique, like unit testing, like system testing. Whereas if we are doing a construction projects, we might have a test to strength the column or some other kind of non-destructive testing. And for example, if it is a car that is being, the project is to design a car, a new model is coming out, then we might even take it for a destructive testing. So the kind of testing that we'll do will differ from project to project, from deliverables to deliverables. And then it needs to be remembered that quality is not an option. I mean, not to have a good quality is not an option, because if there is a failure, quality failure, there can be serious negative consequences. You might lose the business, even the company, the organization the success of the organization will be at stake. So quality failure is not an option yet, because it can have serious negative consequences. There are certain consideration when we talk about quality, important consideration. Basically, when we talk about quality, it is about the customer satisfaction, because when we have maintained the quality, when we have a focus on quality, we are talking about the conformance to requirements. Basically, we have drawn the requirements and we want to ensure that we are conforming to requirement and it is fit to use. So that is really the object, and when we do that, we are getting satisfied customers. Second thing to understand is we should strive for prevention more than inspection. Both will come in play, but where prevention should be given more emphasis in the inspection, because prevention will provide a process that will be quality effective, and there will be less issues to really correct. So quality should be built into, rather than we look at what errors are coming out and fix those errors. Now, just having this quality correcting the quality of preventing is not enough. We should look at the approach with an idea of continuous improvement in quality, so that as we move on forward, we are coming up with better and better quality. And that one of the example is the PDCA cycle, or plan, do, check, act cycle. In other words, we plan it, we do it, and we check how we are doing, learn from that, and then put that learning in that cycle, and then act on it, and then go and plan again. So this cycle gives us a continuous improvement. Now, quality, of course, everyone should participate, the team should be actively involved, but it also it's also a management responsibility. And then finally, we also need to understand the cost of quality concept. And when we look at what is the cost and why we are spending so much, we need to compare this total cost of conformance against the non-conformance. So that will give us the perspective of why we are spending in the quality, and that is really the cost of quality concept. We'll talk about it more. There are some essential concepts that we need to understand as we move through into discussion on quality. First is quality versus grade. When we talk about quality and grade, there are certain key differences between quality and grade. The quality, when you talk about quality, it is really about degree to which requirements are fulfilled. We talk about conformance to the requirements. Whereas when we talk about grade, it is typically by design. Some functionality or same functionality, but different characteristic. So we are providing the requirements, but there is the different degree of requirements. We'll have an example here. So now, if there is a quality failure, that is a problem. Quality failure is not an option. Quality failure is a problem, and we should never have quality failure. We should strive to, arrest any kind of quality failure. For example, if there are defects, these are quality failure. If there are no documentation, that is a quality failure. So that is a problem. Whereas in case of grade, if it is a low grade, it is not a problem, because we said it is by design. Different grades can be by design. And when we say low grade, it might have limited feature. Let's look at an example. Let's say you are traveling. You are traveling and you have picked an airline, and when you went to go and check in, you realize their system is down, and for some technical reason, even the flights got delayed and you're waiting in the queue. Now that's a quality failure, and that should not happen. And let's say after that, you went into the flight. And let's say I have got into the flight and I have taken a coach seat. And what I find is I have given limited feature, whereas I see the business first class have much more feature, and they are at a higher grade. And now these different grades, when we see there, these are grades. Now I don't have many of the features, and that has been done by design. So there are some high grade and low grade features, and that is not a problem. That is by design. So this is the difference between quality and grade. Quality failure is a problem. Low grade is typically by design. Then we need to be clear about prevention and inspection. Prevention versus inspection. Prevention is about keeping errors out of the process. We have the process, we design the process in such a way that we keep the errors out of the product, the way we move forward and develop the product. As opposed to prevention, inspection means that we are checking if there are errors, and before we release, we correct those errors and keep it out of customer's hand. So prevention is about keeping errors out of the process. Inspection is about keeping errors out of customer's hand. Then another concept is about sampling. Now there are different kinds of samplings. One is called attribute sampling, which is really about does it confirm or doesn't it confirm. For example, you are looking at some feature. Does this feature exist or doesn't that exist? You bought a new phone. Can you make the call or can you not make the call? So that's an attribute sampling, which is yes and no. Compared to that, variable sampling really talks about the degree of conformity. It confirms, but how well it does. When you're making a call in your phone, how well both of you can hear. It can be very noisy and not very clear, but you can still hear, or it can be crispily clear. So this is a degree of conformity, variable sampling. So again, attribute sampling is yes or no, confirms or does not confirm. Variable sampling is how well it conforms, is a degree of conformity. Now that Another concept or difference we need to understand is that tolerance and control limits. Tolerance is the specified range of acceptable limit. Let's say you are manufacturing a pipe and it has to be 3 millimeter diameter. Now 3 millimeter diameter, but there can be an acceptable range or tolerance over there, which we might say, well, it has to be 0.05 plus minus 0.05%. And if it is within that, then that is acceptable. So you are talking about a range, an acceptable range, range of acceptable limit. Compared to that, control limits are boundaries of common variation in a statistically stable process. What it really means, let's say a process is running and we are looking at how, what should be the time. And you are putting a control limit. It should be within this range. And the process is going on and is generating the product within a particular time. But then if it exceeds it crosses the control limit, then you say the process that is going on is a failure because it has failed to give us the output within those control limit. So control limit is a boundary of common variation. There is a variation in what is the upper and lower control limit, whereas tolerance is a specified range of acceptable limit. Now, there are different levels of quality management because in an organization, you will find there are different levels. For example, some are more mature, some are less mature. So if you look at the different levels that can be there when we are managing quality, and we look at it from highest to lowest, what we find is if you have a quality culture in the organization, that is the highest level. When we say quality culture, it means that everything that is being done, every thinking, every discussion, and all the thought process in the organization is around quality. Now, the next level can be, well, it is not present everywhere, but what we do is when we are bringing out a product or project, we start looking at quality right from planning and design. So we don't leave it at the last moment, but we start thinking about quality for this project right from planning and design. And then the next level is when we don't really think from planning and design, but there is a quality assurance or process. So what we do is we look at the process level and we try to ensure that we are having the process in place so that we deliver good quality. Then the next level is where we don't really have a sound process, or rather we don't think in terms of process, but before we release to the customers, we have a quality control in place, and so that we correct any defects that we find before it leaves the shore. And then finally, the most costliest effect is when we let customer find the defects. We don't have a process, we don't think about quality, we deliver what was asked of us to deliver, and we don't even go through a rigorous quality control. And as a result, what happens, when it goes into the customer's hand, they find the defects. Now that is very costly because this is when you start losing business, and customer loses confidence. Now, when we talk about quality, there is some difference how it happens in an agile environment compared to our predictive environment. Now, in agile, what will typically happen, as we know, that it goes through an iteration. We take a very small chunk and we go through the development and everything, and it goes through many iterations. And so what we'll find in agile environment is there are frequent reviews that take place. Frequent reviews that take place, and through recurring retrospectives. When we say retrospectives, if you remember, these are reflection, self-reflection by the team. And the team, when they self-reflect, they are going to determine what is going wrong, how it can be improved. And as a result, the process gets, becomes more quality conscious when it goes through that. And also because it goes to a small batch and frequent deliverables, the quality is really gets built into the process when we take an agile approach. As opposed to that, in predictive, we go through the development or the project, and at certain points, probably someone will come in and do the quality check. So it is not as inbuilt into the whole thing as it is in the agile process, as it can be in the agile process. Now let's look at the first process, which is the plan quality management. The plan quality management, when you look at this process, the inputs that we'll get will be project charter, project management plan, documents, and the tools will come across many different tools like data gathering, data and decision making, testing, and so on and so forth. And output, the key output that we are going to get here is the quality management plan. Now, there are different analyses that we do when we are doing the quality planning. So one is we do some kind of benefit analysis, and one of them is really looking at the cost of quality effort. We determine many of the quality effort, quality steps that we need to take, and we look at the cost and also try to find out what is the benefit that is coming out of that. So we do some kind of benefit analysis, and as well as we look at the cost of quality, which really about what are the quality related costs across the life of the product. It is not that we just want to have a narrow view of how much this quality step is going to cost, but then we should also look at, if we don't do it, what is it that will cost us in the long run, and that is the non-conformance cost. Now let's look at what we mean by the cost of conformance and cost of non-conformance. Now when we look at the cost of conformance, the cost of conformance are those quality costs that we spend to avoid failures. And they are such things like prevention cost. There are two categories here. Prevention cost. For example, when we put the team through training, now that's a conformance cost, because we're putting them through training, they can deliver better product, quality product. We document, so that will give us better product. We might get some equipment or some tools there, and that will cost us additional cost, but the idea of getting those and spending, making that extra expense is to ensure that have a good quality product. So that equipment cost or time. So we provide more time instead of as soon as we finish an unit, we release it. We, instead of doing that, we, after an unit is built, we are going to put extra testing effort, and so we are putting extra time to ensure that it is right. Or even when we are doing the work, we build in some review effort and put more time so that we get right the first time. So these are what we say prevention costs, and these are the cost of conformance. As opposed to that, there are some appraisal costs. For example, we do the testing. We are doing destructive testing, or we're doing inspection. And we are here, what we're doing here are assessing the quality before it leaves the shore. And this is what is called as appraisal cost. These are also cost of conformance. So cost of conformance, there are two types of cost of conformance. One is the prevention cost, and one is the appraisal cost, like testing, inspection, and so on. The other side is cost of non-conformance. The cost of non-conformance is about what happens when we fail to deliver quality. And there can be there are two categories of that. One is internal failure cost. Now, internal failure cost is like, it has not gone off the shore. We have not really handed over to our client. It is still with us, but when we are doing that, we find that things don't work, and then we have to rework, or you have to scrap a part and again redo, and it adds up to the cost when we do this kind of things because of some failures that have been found in the project. And these are internal failure costs. As opposed to the internal failure cost, there's another category which is the external failure cost. Now, external failure cost is much, much more costly. And these are the costs that are failures found by the customer. And when customer finds issues with the product that you have delivered, there can be liabilities. For example, there might be something in the contract that you have to pay if something doesn't work, and some other liabilities. For example, we have seen many of the car companies, because of some of the failures, they might be slapped with some fines and so on and so forth, and this can be huge. And there can be some warranty work because you have provided them that it will work and will support you, guarantee for 1 year, 2 years, and if it doesn't work, you have to go ahead and fix them or replace it, and that costs. And finally, if the customer is not happy because they found errors and their failures in what you're providing, then you will lose business. And these things goes around. Not only you lose business with this customer, other customers, potential, you will be losing other potential customers. So external failure costs can be much more costly. So you see, there are two categories when we talk about cost of quality. One is cost of conformance, and cost of non-conformance. Now, if anyone asks you why you are spending so much in the quality, you can always discuss both the sides and explain why trying to build in quality, putting in effort on quality is so important for the business. Now we'll discuss a few basic quality tools. Instead of discussing these quality tools in each of the processes, I thought it's worth looking at them together. So the first is what we call the cause and effect diagram. It has different name. For example, it is also called fishbone diagram because of the shape it has. Or it is also called Ishikawa diagram. So because of the whoever founded that. So this cause and effect diagram, the whole idea is when you find an issue, you try to go deeper and deeper and really try to see what is the root cause. For example, here we find a product where the quality is not matching the requirement. So then we try to go one level deeper. Okay, it is not matching the requirement. Why? Is it because of the material? Is it because of the environment, management, people, equipment? Why? And then once we go at that level and we realize probably that people is fine, process is fine, but probably material is the problem, then we go one level below and see why. Is it the delay in arrival? That's what the problem is, or the low quality of raw material. So you see, we go one level and one level till we arrive at the root cause. So this is called cause and effect diagram, or Ishikawa or fishbone diagram. Then there is another one, which is the flow chart. You look at the flow and then you map the flow and see where things might have gone wrong. So for example, in this flow, there will be some processes. What are the processes involved? And when you draw the flow, you will see what are the decision points in the process. And you look at that and analyze the flow through the flow chart. And then you can determine where might the problem be. Then there is another, which is check sheets. Now check sheets, when you are controlling, probably you will look at different kinds of things and how often this is happening. And you will find out for each date and then take a stock and see where things are coming from, or what are the most of the problem, what is the trend, and so on. So you can use the check sheets, this particular tool, which is check sheet, to determine that. Then there is this concept of Pareto diagram. Now Pareto diagram essentially says that 80% of effects come from 20% of causes. So when we look at the errors that is coming, probably 80% of errors are coming from 20% of causes. And if we look at that, so the way we'll do is, we are going to put down the errors from the highest frequency to the lowest and draw a cumulative curve. In here, for example, we are on the x-axis, we are showing different types of errors. And on y-axis, we are showing the frequency of those errors. And we have put in descending order, meaning a shrink is giving us the highest error, and then porosity and so on. And so we are putting the descending order. And the line that you see is the cumulative. So for every point, we are adding, whatever is in before. So in this particular case, like we said, it is the type of errors in the x-axis and frequency in the y-axis. Here, at this point, the curve says that porosity and shrink, because that point in the curve is cumulative, and it is a cumulative of both shrink and porosity. And porosity and shrink, these two errors, gives the frequency is around 80% and gives you the 80% of the error. So in other words, if you really resolve this, instead of focusing on something else, if you focus on these two and resolve these two issues, you are actually solving 80% of the cases. So this is how the Pareto diagram helps us in determining where we should keep our focus. Then there is a histogram, which again, we draw in terms of, where we get, the values, and we draw a histogram, and that histogram, that shape will tell us where we should be focusing most. Now, control chart is another way or another tool which helps us, especially where there is a stable process going on. In this particular case, let's say you are preparing something, and in that particular process, or you are running a process. Now, you are running a process, and in that particular process, there is an expectation that your the time should be between this and this. And so what you are going to do is you run the process many times and then find out how much time it takes. And you draw in this way as a control chart. When you do that, and you expect that this should be the average time. So what we do is here, once we have determined or have an expectation of what time we should take, we determine what should be the upper control limit and what should be the lower control limit. And we say that this process should vary between the upper control limit and the lower control limit. And if it exceeds beyond the upper control limit and the lower control limit, then it is a failure of the process. So, or sometimes we will also say that if there are quite a few consecutive points above the average or between upper control and average, then it is a failure, as well as if there are consecutive points below the average, that's also a failure. So if that, we might say that the process is a failure if data exceeds control limit or 7 consecutive points above the mean, 7 consecutive points below the mean. So this is one way we can say that the process is a failure, and when we come across this condition, then we go in and try to explore why it is happening, what corrective action or corrective measures that can be taken. Then there is this tool which is called scatter diagram. Scatter diagram, basically, we map the correlation between two variables, input and output, and plot them in a graph and see how they are related. And once we do that, we can draw a trend line. We can draw a trend line. Does it mean that as one goes up, another goes up as well? And so we can, for example, in this here, we have drawn the scatter diagram saying that temperature and pounds per square inch, the pressure, and in a certain environment, we're saying that as temperature increases, what is the pressure? So this is just an example in one of the chemical factory, but it can be anything. So when we do that, look at the scatter diagram, we find, as we are talking about, that it helps us to understand correlation between X and Y about two variables. And we can draw the regression line, and that regression line can be used to estimate how independent variable influences dependent variable. So, and so if we take an example, what we'll see in the top left, we are seeing a trend line, which is, we are saying, positive and linear. Now, this one, so as you're saying, this, if you look at this top left, we'll see this variables x and y are related in a positive and linear fashion. Now, positive and linear fashion meaning that as x increases, y also increases. Now, if we look at this one, we see that they are related in a negative and linear fashion. In other words, they have a linear relationship, and if x increases, y decreases. In this particular case, we are saying it is negative and non-linear. The relationship is not linear, but they, as x increases, y decreases. And in this particular case, we see that there is no relationship at all. So what is really happening here in the scatter diagram, when you plot them, we can see what kind of relationship these two variables have. Now, there are some additional quality planning tools. One is benchmarking. Now, benchmarking is really about we are comparing with some other benchmark. For example, we want to see if the time, the response time, how well is the response time? Maybe we don't have anything with us to really determine. So we might take another similar system somewhere outside, some other system, see what kind of response time they have, and we can do the benchmarking based on that. Design of experiments are when we do some kind of experiments, in the sense that maybe there are many different factors that gives us the output. And so, and we are not sure, or we want to understand what happens based on these different conditions. And so when we do that, for example, if you are running a very processing intensive computation in a server, now the speed, the performance might depend on many different things. May depend on the I/O, might input output speed, might depend on the memory, might depend on the processing speed. So you vary all of them and try to figure out what is really influencing the performance. So this is in a way, it's a design of experiments, because we are trying to see, use different variables and see which are the factors, a combination of factors that are really influencing your performance. Statistical sampling. Many times you would like to know, get the results. For example, you are dealing with, let's say, hundreds and thousands and millions of customers. You are going to roll out your new website, and you want to take some inputs. You want to find out what is the quality, how we can do better, and all that. If you have to go through all the customers, that will be very costly. And so what you will do is you will take a small sample of the population. And there are different ways you can do sampling, of course, and with different objectives. That's another study altogether, or another subject. But you can take a small subset of the population, take input from them, and you can choose, basically this is called statistical sampling. Then brainstorming. You can do a brainstorming to generate ideas. You get a small group of people, ask them to give you ideas and inputs, and then you use that, try to use that. Along with brainstorming, you can do something called nominal group technique. Now, nominal group technique is when you take all these ideas that you have from brainstorming, and then you take through a review process with a larger group. Review process with a larger group, where you do the voting maybe you can do voting and see, which are the ones that you should take into consideration. Now, this plan quality management will have quality plan management plan as the output. Now, in this particular plan, what you will have is quality standard, the processes that you will take to quality standard. You will put together what are the processes that you will use for quality objectives, what should be the quality roles and responsibilities, and what are the project's deliverables and processes that should be subject to quality review, and what should be the quality control and management activities. So all these different things you'll put together in the plan, so that in the next process, when you go into the next process, you can take this and determine what are the activities and how should plan it out. What are the quality tools, and what are the major processes? Let's say conformation, non-conformation. What are the processes that you find it relevant for this particular project? So in the quality management plan, you will put this all together, so that this document will provide a guideline for your next processes. Our next process is manage quality. In manage quality, the inputs will be project management plan, documents, and when we say project management plan, the main one will be the quality management plan, and there will be different project documents and OPA, and we'll use different tools. And the main thing that will come out will be the quality report and some test and evaluation documents. Now, manage quality in lot of departments is also called, on a lot of organizations, also known as quality assurance. Now, in fact, in the 5th edition, the process was quality assurance. Now, and that has been changed to manage quality in this particular edition, because what is felt that we need more than just quality assurance. And in this manage quality, it is not about just quality assurance, it is much more than that. Now, of course, we take into consider quality assurance, which is about ensuring that we have effective processes we have in place that will give us quality product. So that, and that is the whole idea of the quality assurance. But managed quality not only takes in quality assurance, is about quality assurance, but also it takes quality during product design. And it will also take into consideration the improvements. It is not that we have to, or we need to focus on the quality process. We should, when we're designing, we need to think about the quality. And when we are doing the quality, we should also look at how we can continually improve. That is the whole objective of managed quality. And this process will define activities based on the plan with this objective in mind. Now, when it does that, there are different outputs that we get out of the managed quality, or different benefits we get out from this managed quality process. One is we'll be designing an optimal and mature product. And when we do that, there will be confidence there if that the future outputs will be of a higher quality. Future outputs will be of a higher quality. And it's not only, it will give confidence. Our customers, our client will be more confident, they know they can rely on us on quality. And it will of course, confirm use of quality processes. And because we are also focusing on process improvement, there will be improvement in efficiency, effectiveness, and even going forward. Now, this whole thing is not only about the project team. It's not only that the project team will be working on through this. Everyone in the organization and even the customers should get involved. So this quality effort, the managed quality, should be everyone's business. It should be the project team, the management, the sponsor, the client, the user. Everyone should get involved in managing this quality. Now, there is slight difference how this is done between waterfall and agile. So let's have a look at that. In agile, in waterfall, typically what happens is there is one person or one department who is really involved, and the team does the work, and at different interval, someone from the quality who is responsible for the quality will come and either audit or will do the testing and so on. So this is really what happens in a typical waterfall model. As opposed to that, what happens in agile projects are, as you're going through the iteration, the whole team at different points in the iteration will get involved in the agile process. And like we said, they'll do the retrospectives, they can switch their roles, reviewing each other's works and so on. And in doing so, this quality effort is built in, or rather should be built in, into the whole process. Audit is another tool that is used in managing the quality. So when we do audit, what happens is maybe someone from within the company or from outside will come and look at how the project is being done. And it can be done at different points. It can be done at the beginning, how the processes have been set up for this project, and it can be done at different stages to ensure that the project is following the quality process. So, and the whole objective of this audit is to identify all the good and best practices being implemented. So what are the practices this project is implementing? And if there are any non-conformity, anything there is any gap, audit will identify, and the best that they identify early, it can be corrected as soon as possible. They will not only identify the non-conformity, they'll also share good practices from organization, because remember the audit group, they are conversant with, because there's been audit, they are going around and doing auditing for different projects, and they know, or they have learned through time, what are the different good practices that is available. So they can share that with the project for the benefit of the project. Now it will assist to improve implementation process and raise team productivity when you take in those good practices in your project. And if there are any higher contribution, audit contribution you find in the audit process, then, or the lessons that you've learned through that audit, you can put that in the lessons learned database so that future projects can benefit from that. Now there is this concept of design for X, and which really is about the technical guidelines. These are the technical guidelines, and that is used for the product design. Like we said, in managed quality, we want to focus in right from the design, product design. And the whole idea is that we are designing with X in mind. And this X can be many different things, like different aspects, like reliability, deployment, assembly. So when we are using these guidelines with that particular aspects in mind, and we look at different aspects as we do the design, we get different results, positive results. We can get cost reduction, we have improved quality and performance, we'll get customer satisfaction. But the whole focus here is, and this approach is, we are designing right at the start. We are designing very specifically with a very specific focus on these different aspects. Now, when we are going through this quality, we will come across many problems, many issues that needs to be resolved. And one should, or in a project, we should look at it methodically and take the structured problem approach. And sometimes we might have always used this. It's possible that we have been using this structured problem approach, but we want to ensure consciously that we are using this approach. Structured problem steps, not only one person, but everyone involved in the project. So, especially when we are managing the quality. So the way it happens is, the different steps that is involved in the structured problem solving approach is, first, we define the problem. We don't just jump into the solution. We define the problem and we analyze it. We identify the root cause, because unless we take the step number 2, it can happen, we can just try to resolve the symptom and not the root cause. So first we define the problem, we understand the problem, then identify the root cause. Then once we identify the root cause, we just don't jump into the first solution that comes to our mind. We look at different possible solutions. We look at different possible solutions and then analyze and see which solution is best under our circumstances, and we select that best solution. Once we select that best solution, we implement that solution, and we are not done with that. After that, we need to verify the effectiveness of the solution that we have chosen. Because if it has not, then we might have to review the process again. The next process we'll touch upon is the control quality. The control quality, this process, the inputs that we have are project management plan, documents, change requests, deliverables, because we, at this point, we have the deliverables. Now we are about to release it to our customers. So we will take that in and do whatever needs to be done and check, inspect, test before we release to the customers. The kind of, there are different tools, and most importantly, inspection and testing evaluations that we'll do. And finally, what we're going to get is a verified deliverables, amongst others, where verified deliverable is what we release to our customers. Control quality essentially ensures that the output are correct and it meets customer expectation. This is the objective of this particular process that we have. And these deliverables should meet the requirements. This is what we are focused on in this particular process, which is a control quality process. Now, it is not that this control quality is done only at the end of the project. It should be done throughout the project, the control quality, to ensure that we are delivering the correct product to the customers. And of course, the way we implement will differ by industry. Degree of implementation will differ by industry, because as you can imagine, the way we do these things, inspection or quality checking in construction, will be different from the way we do it in the software, in healthcare, and in the car designing, whatever we think of. So each will have its own way of how they implement this particular process. One is inspection. Inspection is really about examination of the work product. And again, as we said, it will differ application area by application area. But some of the ways we do inspections are reviews, or we do peer reviews. For example, we have done the work, someone in another group will do, and then there can be audits. They'll keep checking that we are on the right track, if things are going according to this thing. And again, the way this checking, the inspection is done is different. For example, in the construction, the way you do the inspection will be different if you are in, let's say, software or some other industry. Testing and product evaluation. Again, testing is really a organized and constructed investigation. Basically, the idea is to test and find if there are bugs or errors and defects and non-conformance. Now, there can be destructive testing, there can be non-destructive testing. A lot of times, what we do is, most of them are non-destructive, right? And when we are testing and see the result, comparing what should be the expected, we might have some test plan based on which we will be doing the testing. In many cases, it might be destructive. We actually take it to the extreme, and especially when they come up with a new car model, they'll take it through a lot of destructive testing to ensure that all the safety measures and all the different features are goes through a rigorous testing process. And when we do testing right from the beginning, it helps us reducing cost. So because if we have an error and we take it through and we find that error at the last moment, fixing it can become costly. Whereas if we find it early on, fixing that error will be less costly. Outputs from a controlled quality process is verified deliverables. The way we said, verified deliverables is now. We got the deliverables, we verified it, we are ready to release to our customers. And all the measurements that we have done, how we have done the control quality, all this will be documented. All this will be documented, and that also will be one of the output. And finally, also work performance information. The information that we gathered through that quality control process. And because of the quality control, there might be some changes coming, and change requests will be raised, which will go into direct and managed work so that these changes can be addressed. Now, with this, we finished this particular module, project resource management. And in our next, we have finished this project quality management. And next, we'll touch upon our next process, which will be project resource management. And we'll look at it on Monday. Thank you and have a good weekend.